Hello, physics students. In this tutorial, we are going to have part 2 of free fall. So we're going to cover a little bit of a more challenging problem. So I want to set the stage for you as to what type of problem we're going to look at today. So I want you to imagine that you are a physics student, because you are, and you are so excited about physics one day because you get a problem right that you leap into the air. And this is how high you get. And then, as we know, gravity is going to take us right back down. So, as we look at this in total, we have you standing here, you go up, and then you come back down. So this represents the entire picture. So there are a couple things that just by drawing this diagram, we can actually label to help us to be able to solve for anything that we could possibly want to find. So let's look at the displacement first. Well, there's two types of displacement. There is this idea of the change in y max, or I call it the maximum height that you got from the ground. But if we look at, if we think about the change in y or vertical displacement in total, what do you think it would be? It should be 0, right? Because you start at the ground and you end at the ground. So the total displacement vertically is 0. But we can actually focus and use this idea of maximum height to maybe be able to solve for something. Because there's something very special about right up here. Do you know what it is? Well, velocity right at the top here is 0 for just a moment, right before you start heading back down. So this idea that the velocity is 0 is something that we could possibly use to solve for something that we don't know. And lastly, the other thing that we can always know is, this is in free fall, the second you leave the ground. So what is your acceleration? Hopefully you said negative 9.8 meters per second squared, because the object is in free fall. So let's talk about the other variables. What variables do we not see here that we can still talk about? Well, I'm going to provide a little list and I'll talk you through it. Okay, so we have the initial velocity, which we're used to. The initial velocity in this case would be the takeoff speed. So as you push up off the ground, you're going to cause yourself to have a velocity upward. The second you leave the ground, you're actually going to slow down. So the initial velocity is this takeoff speed right when you leave the ground. When we talk about change in time, well, the total time in the air is all the way up and then all the way down. So the time that it takes to get to the maximum height, or what this displacement represents, so just the way up, would be half of the total time. So this is just an example. We're not actually going to solve anything here. I just wanted to show you all the possible things we can look at when we have something jumping up or being thrown up into the air. It still qualifies as free fall because, as we know, free fall is any object that is only under the influence of gravity is experiencing free fall. So it experiences an acceleration due to gravity of 9.8 meters per second squared downward. So by simply drawing a diagram and labeling it to the best of our ability like we did here, and recalling all the other variables and what they might mean for each scenario we're given, we can set ourselves up really nicely to solve for anything that we might need. So let's jump into a problem together, pun intended, and we'll start solving for something. Okay, so here we have a problem. It says a baseball is popped straight up into the air and has a hang time of 6.25 seconds. Determine the height to which the ball rises before it reaches its peak. Hint, the time to rise to the peak is 1/2 the total hang time. All right, so we're given a little bit of information. It doesn't seem like a lot, so let's figure out what we can do with this problem. The first step is to try to draw a diagram. I want you to pause the video and try to draw a diagram of this scenario. Ready, set, go. All right, so this is what my diagram looks like, and I encourage you to add things that you might have forgotten. Okay, so here's my awesome baseball player, baseball hat, see it? Baseball thrown up into the air. So the red represents that it's slowing down and then it's speeding up. So you see the arrow's getting bigger as it goes down. And then right here, I always like to label, when I get these problems, the velocity at the top, because that's going to be an important given when we solve for something. And then I also like to say, well, I know that this is my maximum height, so change in y max. And then I make a note to myself, okay, don't forget that the total time is not just how much time it takes to get up, but the total time includes the time it takes to get down as well. So the time to the max height is actually half of the total time. And that's basically what this hint is trying to tell us here. All right, so the next step is to write our givens. So I would like you to pause the video again and try to write down all the givens that we know. Now, before you pause the video, I want to point out that we are trying to find the maximum height. So we're going to be dealing with half of the problem because we're trying to find the half of the displacement. And so I encourage you to write out your givens with the maximum height in mind. Okay, pause the video, ready, set, go. All right, so here's my givens list, and again, add things that you might have forgotten. Okay, so again, because we're trying to find the height, I specifically make a givens list that is givens to my maximum height. So the initial velocity, the problem doesn't tell us anything about initial velocity. Final velocity, though, at the top here, if I'm just looking at the first half of the trip, and this is my initial velocity, my final velocity up here would be 0 because, like I said before, this is going to be helpful in solving problems. I know that acceleration is negative 9.8 meters per second squared because the ball is in free fall, so it's experiencing an acceleration due to gravity. And I know that my time to the maximum height is half of the total time, which is this hang time that they give us. So 1/2 of 6.25 is 3.125 seconds. And I'm looking for a change in y, or vertical displacement. And I'm looking for the maximum height. Okay, so I'm going to bring in the kinematic equation so we can take a look at what equation we might want to use to find this maximum height or vertical displacement. Okay, so there is a mini version of our kinematic equations, and I want to look for an equation that has everything that I have and everything that I'm looking for. So, I don't know if you see it, but every single equation has initial velocity in it. So, it looks like I'm going to have to find my initial velocity first, and then I can find the vertical displacement, or the maximum height. Okay, so I picked the first one because it has final velocity, acceleration, and time, which I know, and it has initial velocity. So then I just plug everything in because I'm solving for initial velocity. So 0 is my final velocity, negative 9.8 is my acceleration, and 3.125 is my time because I'm only focusing on the trip up. And then now it's just algebra. So I multiplied these two here to get 30.625, and it's negative. And then I need to subtract that. And then I'm left with my answer. Initial velocity, or the takeoff speed of this ball, is 30.625 meters per second. So I've got my initial velocity now, and I can finally solve for maximum height. So I would love for you to pause the video and try to solve for maximum height. Try to pick the equation that you think is best and go ahead and solve, and we'll see if we get the same answer. Ready, set, go. All right, let's check it out. I'm going to minimize this little diagram. And I selected, let's see, I selected the third equation. You could actually pick any of them except for the first one to solve for change in y. And again, here in the actual equation, it's change in x, but we know that that means horizontal displacement, and we could just change that to a change in y for vertical displacement. Okay, so here is my solution. So final velocity, I rewrite the equation, and then I just plug everything in. Final velocity, initial velocity squared, 2 times 9.8 negative times our change in y, which is what we're looking for, our vertical displacement. And then it's just an algebra equation. So you should have gotten 47.85 meters or 47.9 meters. And that represents how high the ball goes up before it comes back down. I hope that was helpful for you. Please write down any questions you have.